So now we are at Module 3, Section C. That's the calculus section of the paper. Question 5 and 6. So we'll begin with 5a, which is a limits problem. Alright, so the limit as x approaches infinity. So x approaches infinity. So what we can do is a very basic method of finding the solution here, the limit here. So limit approaches infinity. Look at the highest power in the entire function. So in the entire function, that's in both the numerator and the denominator, the highest x power there is 4. So you look for the highest power, x to the power of 4, and then you look for the coefficient only for the highest power here. So the highest x term here is x to the power of 4, and its coefficient in the denominator is 3. And in the numerator, notice there's no x to the power of 4, which means that there's no coefficient. And for no coefficient, we represent that. We use a 0 to represent that. Alright? And 0 divided by any non-zero number is 0, so the limit is 0. And by the way, this method only works for when x approaches infinity. Alright, let's move on to the next section. And that's part B, which is a limits problem. Sorry, it's a rate of change problem. A student goes to the water cooler to get a drink of water. The student has a cup in the shape of a cone. As we can see, there is a cone. The radius there for the circular part is 8, and the height of the cone is 16, as the question is telling us there. The question says the water from the cooler is filling the cup at the rate of 12 cm cube per second. So the rate is given. Notice cm cube, that's volume. Seconds is in time. So we are given dv by dt. So dv by dt is 12 cm cube per second. That's 12. And how we know it's dv by dt is cm cube. That's volume and seconds time. So volume over time. Alright, so we are told that the height is 16, as we can see in the diagram, and the radius is 8. How fast is the water in the cup rising when the height is 4? So we're asked how far is the water in the cup rising. So rising, that's what? Rising the height, so that's dh by dt, so it's rising. So we want the rate of change of the height. Alright, how far? So as we want the change in height over time. So dh by dt. So using the rate of change formula, chain rule, that's dh. So the numerator and the first fraction here have to have h at the top. So dh by dv times dv by dt. It's almost as if dv cancels itself there. So you're left with dh over dt. Alright, so using the chain rule. Alright, so I want to find the dh by dt. Alright, now dv by dt, we already have dv by dt, that's 12. So dv by dt is 12. So what we need to find now is dh by dv. Now the question tells us that v is a third pi r square h. So the question says v is a third pi r square h. So I could differentiate with respect to h. So I could find dv by dh, and we just flip it to get dh by dv. Now dv by dh, I'm going to differentiate the h variable here. So we're going to rule for differentiation. I'm going to multiply by the h power and subtract 1 from the h power. Alright? So multiply the entire term by the h power, which is 1. So 1 times the term, so it's 1 times 1/3, that's 1/3 pi r square h, and we subtract 1 from the power, you get 0. And h to the power 0 is 1, so all we have is just 1/3 pi r square. Or you could say pi r square over 3. That's dv by dh. Now what we want is dh by dv. So if you have dv by dh, to get dh by dv, just flip both sides. So look at it as pi r squared over 3. So dh by dv, we just flip it. So dh by dv will be 3 over pi r squared. So what we need now is a value for r. Now how can we get the r value? Now we are told that when r is 8, h is 6. So what I want, we are told here now, we want the solution for when the height is 4. So if h is 16, so 8 height, let's look at the ratios, height to r. So when the height is 16, there's a triangle there, there's a right angle triangle, this is actually. So when the height is 16, the radius is 8, which means that when the height is 4, we can get the corresponding radius. So we can use our knowledge of ratios to get the corresponding radius. All right, let me call it x. So if you look at this ratio, if you divide by 2 by 4, you get 4 here, and you divide by 4, so this is 2. Another way to find x, maybe you could cross, well, would it work? Yes, you could cross multiply, and what you'll get is 16x equal 32, and if you divide both sides by 16, you'll get 2. So if the height of 16 gives you a radius of 8, a height of 4, as we are told here, gives you a radius of 2. So we can replace r with 2. So this is 3 over pi times r squared. Now r is 2. When the height is 4, r is 2. So r squared will be 2 squared, and 2 squared is 4, right? 2 squared is 4. So times 12. So this would simplify now to well, this is 3 times 12, that's 36, divided by 4 pi. And of course we can reduce by dividing 2 by 4. So divide 2 by 4, we get 9, 4 into 36. Yeah, 4 into 36, that's 9, right? So that's 9 over pi. And it's height over time, and what's the unit for height? Centimeters, and the unit for time, seconds. Part C, a manufacturer of containers wants to make a container in the shape of a cuboid, that's a box looking thing, with an open top. The container is made from a flat sheet of metal of 16 meters and a width. So let me just do a sketch here. A picture is worth 1,000 words, right? So here's a sketch of the flat sheet of metal. So it's a 16 meters by 13 meters. Alright, and we're told that squares of length x are cut from each corner of the sheet to create sides. So from each side, so squares from each corner. So squares of length x meters are cut from each corner of the sheet. So I guess, so there's 4 corners. So that's how I'm interpreting it. So x. So these are some squares, and the length. So x, right? Another square. All the sides are x. So x. All the sides are x, right? Another square, x, another square, x. So when these are cut now, I guess now they are used to form a box. So, and remember the formula for volume of a box is formula for volume. What's the formula for volume? Volume is equal to length times width times height. All right. So the length and the length here, this is cut from it. So the length here will be 16. Notice x is cut from this side, and x is also cut from this side. So in all, it's 16 minus 2 x's. All right. So the length is 16 minus 2x. Alright? And the width, again, the width is 13, but x from the left, x from the right. Alright, so we are left with 13, subtract 2 x's. And now the thing will be folded up now to form the height. So the height of this box will actually be x. Alright, the height of the box will be x. So I guess this was cut and used to create a box. So the box maybe look something like this. Alright. So the height will be x when this is folded. So I guess what will happen is that what we'll have, so these, let me just use a reading. I guess these parts now will be cut from it. This will be cut from the box. And then now it will fold it now to form a box. So the height of the box should be x. Anyway, that's my interpretation. Let's expand and see if we get what they say we are supposed to get. Let's go back to a color I was using. Alright, so the volume is equal to, let's expand the bracket. So let me leave the x outside for last. So let me expand these two brackets first. Alright, so 16 times 13. Okay, so 16 times 13, that's 208. 16 times negative 2x, that's negative 32x. Alright, then negative 2x times 13, that's negative 26x. And negative 2x times negative 2x, that's 4x squared. And then yes, and then we'll leave that, so leave x outside. So we have v equal to, we can group the like terms. So this is if we group the constants, well, only 208 is the only constant there. 208. The x is minus 32 minus 26. I don't keep a sign. That's negative 58x plus 4x squared. And then we have x outside, right? We have x outside. Let's multiply each term in the bracket by x now. Let me start from. So x times 4x squared, that's 4x cubed. Put the x cubed at the front. X times negative 58x, that's negative 58x squared. And x times 208, that's 208x. So we get what we're supposed to get. Using the method of second derivative, determine the height x, that will maximize the volume of the container. Using the method, using derivative, determine the height x, that will maximize the volume of the container. Alright? So now that the volume, rewrite what we have for volume again. So volume equal to, what was it? So it was 4x cubed, negative 58x squared, 208x. Alright, so 4x cubed, negative 58x squared, plus 208x. Alright, so to get the maximum, to get the value of x that will maximize the volume, we equate dv by dx to 0. Alright, so dv by dx, let's find dv by dx, so multiply by the x power, subtract 1 from the x power, so 3 times 4, that's 12x squared. 2 times that, that's minus 116x plus 208, and we can equate that to 0. Alright, so we have a quadratic here. Can we simplify? If we try and divide through by 12, we try and divide through by 12. 116 divided by 12, that's some decimals there. So it seems like we're going to have to, let's use the quadratic formula to solve it, alright? So the formula, quadratic formula, x is minus b plus or minus square root b square minus 4ac over 2a. So this is my a, this is my b, and that's my c, right? So let's do the substitution. So minus b, so b is negative 16, so minus b is positive 116, plus or minus b square, that's negative 116 square, minus 4 times a times c, so minus 4 times a is 12, times c is 208, all over 2 times a is 12, so all over 2 times 12. So we can work this out. Let me just x equal 116 plus or minus on everything there. Well, the denominator 2 times 12, that's 24. In the square root now we'll have negative 16 square. So that's 116 times itself. I should get a positive number, right? So 116 times 116 minus 4 times 12 times 208. And I'm getting 3472. Alright, so in terms of the values now, so therefore this is equal to 116 plus or minus, and the square root for 3472, use 2 decimal places. So I'm getting 58.92 over 24. So what this means is that the x is equal to, so let me just write it out. So x is equal to 116 plus 58.92 divided by 4. So I'm going to write that out. So x is 116 plus 58.92 equal, press equal sign, then divide by 24. I'm getting 7 point, let me just use 7.3 or 7.3, or x equal to, I subtract now, so 116 minus 58.92 equal 57. Then I divide now by 24, and I'm getting 2.38. Let me put this in 2 decimal places. This was what again? So this was what now? 116. It should have been 7.29. Alright, so now we have 2 x values. We need now to determine which one of them maximizes. Alright? So we need to find the second derivative. So dv by dx, we need to find the second derivative now. So d2v by dx squared. So we're taking the second derivative. The second derivative is equal, so here was the first derivative, right? Here was the first derivative. Alright? So the second derivative again, multiply by the x power, subtract 1 from the x power. So 2 times 12, that's 24. Subtract 1 from the x power, that's just x to the power 1. Multiply by the x power, that's negative 116 x to the power of 0, which is 1. So it's just negative 116. And then differentiate any constant, it's 0. So 24x minus 116. Now, the rule is that when the second derivative is bigger than 0, it's a minimum, and when it's less than 0, it's a maximum. So we need to determine which of these x values which let me just separate it. Which of these x values will give us a second derivative that's less than 0? And let me try both of them. So if I substitute x equals 7.29, if I substitute x equals 7.29, the second derivative, let me just call it v double prime. Alright, the second derivative is v double prime. That's d2v by dx squared is 24 x minus 116. So it's 24 times 7.29 minus 116. That's 58.96. That's almost 59, which is bigger than 0. So this minimize it. When it's bigger than 0, it's minimum. Alright, let's work out the second derivative now when the x value is 2.38. So this time I'm going to substitute x equal to 2.38. Alright, so when x equal 2.38, what we have is 24 times 2.38 minus 116, and that's negative 59 if I round off to the nearest whole number, which is less than 0. When the second derivative, 24x minus 16, is less than 0, then that's a maximum. Alright, so we were asked to determine the x value that will maximize the volume. So the x value that will maximize the volume is the smaller value here, 2.39. Alright, so 2.38. So 2.38 will maximize the volume. Alright, determine the maximum volume of the container. So the volume of the container, look at the volume formula again. The volume formula was, what was the volume formula? The volume formula was that. Alright, so we'll substitute the x value and we'll get the volume. Let's restate the volume formula. 4x cubed minus 58x squared plus 208x. So we know that 2.38 will maximize the volume. So to get the maximum volume, we'll replace the x with 2.38. Alright, so it will become 4 times 2.38 cube minus 58 times 2.38 square plus 208 times 2.38. We'll end up with this works out to be, okay, a little later. That's 220.43 and its volume. Remind yourself what the unit was. X was in meters, right? So 220.43 cubic meters. Good. Let's continue. Final question. That's question 6. Calculate the volume of the solid generated by revolving the region bounded by the line y equal 3x minus 6. So this is line y equal 3x minus 6. Here it is. This is line y equal to 3x minus 6. Notice the line, it cuts the y-axis at negative 6. When x is 0, the y is negative 6. And when the y is 0, x is 2. So this is the line y equal 3x is 6. And obviously the quadratic graph would be, this is a quadratic graph. Y equal x squared plus 3x minus 2. Alright, so calculate the volume of the region, the volume of the solid generated by revolving the region bounded by the line y equal 3x minus 6 on the parabola on the interval 0, 1 about the x-axis. So the interval here is 0, 1, x is 0, y is 1. Alright, so let's find the volume. Alright, so of course we'll take the difference between the volume generated by the curve minus the volume generated by the line between the limits 1 and 0. Alright, so it seems to be this area, this region there, right? 0 and 1, 0 and 1. Alright, so the volume formula is the pi times the integral of y square dx between the limits, and we are given the limits, the interval here, 0 to 1. Alright, so we take the difference of the volume generated by the curve and the line. So we need to find out for the line y square and for the parabola also. Now the line, now for the curve, and this is for the line. Let me do it for the line first. The line y equal 3x minus 6. We need to find y square. Y square would be square both sides, y square with 3x minus 6 all square, which is 3x minus 6 times itself. So y square would be 3x minus 6 times itself, 3x minus 6. So y square would be equal to 3x times 3x, that's 9x square. 3x times minus 6, that's minus 18x. And minus 6 times 3x, that's minus 18x again. And then minus 6 times minus 6, that's positive 36. Alright, so for the line, y square is 9x square minus 36x plus 36. Alright, that's for the line. Let's do y square now for the curve. Alright, so for the curve, the parabola, we know y is x square plus 3x minus 2, right? So y square will be, you square both sides, so it's a function times itself, so x square plus 3x minus 2 times itself, which is x square plus 3x minus 2, which means that y square for the curve, so let's expand, it's a long expansion, to expand, so x square times x square, that's x to the power of 4, x square times 3x, at the powers, x powers, that's 3x to the power of 3, that's 3x to the power of 3, right? 3x to the power of 3, and x squared times minus 2, that's minus 2x squared. Alright, continuing. So now it's 3x now times each term in the second bracket. So 3x times x, that's 3x cubed. And then 3x times 3x, that's 9x squared. And then 3x times minus 2, that's minus 6x. And then now we take the negative 2 now and do the exact same thing. Distribute to each term in the second bracket. Alright, so now negative 2 times x squared, that's negative 2x squared. Negative 2 times 3x, that's negative 6x. And negative 2 times negative 2, that's positive 4. Alright, so let's group like the like terms now. So y squared equal to, so if we group the like terms, what we'll have is, so we have x to the power of 4, any other term like that, so it's just x to the power of 4. Let's look at the x cubed term. So it's x to the power of 4, we have that, so we have 3x cubed, so that's 6x cubed. Alright, and we have what else now? 3x cubed and 3x, 6x cubed. let's look at the x squared terms. We have minus 2x squared. We have minus 2x squared, that's negative 4x squared so far. And then the positive 9. So it's 9 minus 2x squared. So 9 minus 2, that's 7. And 7 minus 2, that's 5. So 5x squared. And then now the constant, the x's term, we have minus 6x. We have minus 6x. That's minus 12x, right? That's minus 12x. And then we have positive 4 as the only constant there. So this is the square for the quadratic, square for the line, y equal 3x minus 7, alright? So we need to find the volume now, we need to, so remember the volume is integral of pi y squared. So the volume is the integral of pi y squared. Alright, so we have take the difference, alright? So this y squared, just to ease the letter, this is the y squared for the, and it doesn't matter the order, If you do it and you get a negative at the end, then you just use a positive value. So the order in which you subtract it does not matter. Let me put the line first, alright? So the line here I have x to the power, the curve. I have x to the power of 4. So x to the power of 4, group with like terms, are taking a difference, alright? The curve minus the line. Y squared difference, alright? So x to the power of 4. And then we have 6x cubed. There's no x cubed over here. And then we have 5x squared. Notice it's 5x squared, but we take subtract difference. So here's a 9x squared term over here. So it's 5x squared minus 9x squared. So that's negative 4x squared. And for the x, we have minus 12x. And then we subtract, but careful. So it's minus 12 minus negative 36, which could become minus 12 plus 36. That's 24x. So remember, is the y square for the curve, subtracting the y square for the line. So careful. So it's 5x squared minus 9, and then you have minus 12 minus negative 36. Yes, it's minus 12 plus 36. Alright, that's 24. And then the constant there's 4, take away 36, that's negative 32. So we're integrating the difference there, alright, with respect to x. Alright, so the volume is pi, integral of pi y squared. Alright, so it's pi, and the y squared, we're taking the difference between the line and the curve. The y squared for the line, the y squared for the curve minus the y squared for the line. Alright, let's integrate now. So v, we can keep the pi outside. So v, let's integrate, and the rule for integration, add 1 to the x power and divide by the x power, right? So we integrate x to the power of 4, add 1 to the power, you get 5, divide by 5. Add 1 to the power, you get 4, divide by 4. Add 1 to the power, you get 3, divide by 3. Add 1 to the power, you get 24x squared, divide by 2, so that's 12x squared. And integrate a constant, you just put an x beside it, so integral of that 32 is negative 32x. So we need now to evaluate between 1 and 0. So we form two brackets. Alright, so remember we're pi outside. Alright, so we form two brackets. In the one bracket, you replace the x with 1. In the other bracket, you replace the x with 0. So in the first bracket, replace x with the 1. Alright, replace x with the 1. Now 1 to any power is 1. Alright, so 1 to the power of 5. So that's x to the power of 5. So that's 1 to the power of 5 divided by 5. So that's 1/5. Plus, replace x with the 1. 1 to any power is 1. So that's 6/4. Replace x with the 1. That's negative 4/3. I need more space here. Let me just. Replace x with the 1. That's 12. replace x with 1, that's minus 32. Alright, in the other bracket, I replace x with 0. Notice, same thing. All of these have an x term, so everything will become 0. Alright, so the second bracket will be just 0. Good. And now, so let's work out what we have here. So 1/5 plus 6 over 4 minus 4/3 plus 12 minus 32 will give us, so this will give me negative 19.63, so negative 19.63 times the pi outside, so times pi. So the volume, in answering the question now, just use a positive value. So the volume generated would be 19.63 pi. And remember it's volume, so volume is in units cube, alright? Cubic units. Okay, so we're at part B. Alright, so bounded by cos x and sin x. So here's cos x and sin x. Here bounded between x equal pi over 4 and 3 pi over 2. Alright, so pi over 4. Now this is pi, half pi. So quarter pi would be here, so about there. Here bounded between the curves, alright? So, and 3 pi over 2, here's 3 pi over 2, x equal 3 pi over 2 will be here. So what we want is the area bounded by the curves, so between the curves, alright? On these lines. So the area we want would be the section between the curves. So we have here, so here, and between the curve here. Alright, so notice again, just like the previous with the volume question, we find the difference of the area between the curve. But the thing about it, here we have area above the x-axis and we have area below the x-axis. So usually the area below the x-axis, the area below the x-axis are negative values. Alright, so we don't want to integrate between the entire region. So we're trying to take a difference, but we're going to do it piece. Alright, let me put it in red. Alright, so I'm going to call this area 1, that's between the curve, call this area 1. And area 2, now area 2 will be a negative number. Since it's below the curve, it's below the x-axis, so it will be a negative area. Likewise, area 3, alright, so I split it into 3 sections, alright, so area 1, area 2, area 3, and we're taking the differences, alright, it doesn't matter the order, cos x minus sin x take away cos x, it doesn't matter the order. Let's try and get the limits out of the way now. So for area 1, the limits will be, this is pi over 4, and the limit here is pi. So the first limit is between pi and pi over 4. The second limit is between between pi over 2 and this is what now? Between pi, this is between pi and, well, one thing we notice is that these two areas are the same. Area 1 and area 2 are the same. So if we find area 1, and multiply it by 2, we should get the full area of area 1 and area 2 together, right? So area 1 plus area 2 would be equal to, you just need to find area 1. You need to find area 1 and multiply it by 2. So area 1, the limits for area 1 would be pi over 4 to pi. So pi over 4. And the area 1, the difference between the two curves, that's sin x minus cos x. It doesn't matter the order, or cos x minus sin x dx, right? Let me just write it better. Just chop for space. So to get the full area for area 1 and area 2 there, that's above the curve and below the curve, but below the x-axis, sorry, above and below the x-axis is the integral between the limits. Notice between pi to pi over 4. And the curve is between cos x minus sin x, alright, dx. And of course, we multiply it by 2. Alright, so just find area 1 and multiply it by 2, we'll get a total for area 1 and area 2. Alright, and then, so let's do this quickly. So, change the color. Alright, so integrate cos x. The integral of cos x is sin x, and the integral of sin x is negative cos x, but a double negative, so we end up with plus cos x, alright? Between the limits pi and pi over 4. Pi is equivalent of 180 degrees, pi over 4 is equivalent of 45 degrees. Alright, so notice when you differentiate this, you get back the original thing in the red. So differentiate sine, you get cos. Differentiate cos, you get negative sine. That's how we can check if you integrate something correctly. Alright, so let's work it out now. So we form two brackets. So of course we have 2 outside, and we form 2 brackets. In the first, we're going to replace x with pi. So what we have is sine pi plus cos pi. Now remember pi is 180. So sine 180 is 0, and cos 180 is negative 1. So that's negative 1. Minus, now we're going to replace now, so the first bracket is minus 1. The second bracket, I'm replacing the x value now with pi over 4, or 45, alright? So remember sine 45 and cos 45 is the same thing, alright, root 2 over 2. So sine 45, that's root 2 over 2. Cos 45 is also root 2 over 2. Alright, so I can distribute the 2 now in the bracket. Outside the bracket, sorry. So 2 times that, that's minus 2. Alright, and then, well, this bracket, let me just continue. This, what we'll have here is 2 outside the bracket. And inside, we'll have minus 1, minus, and if you add these, group these together, same common denominator of 2. So add the numerator, root 2 plus root 2. So that's 2 root 2. So what we have here is 2 root 2 in the second bracket divided by 2, which is just root 2. Alright, so it's root 2. So what we end up with when we distribute this is minus 2 root 2. But the area, of course, will be we use a positive value for the area, so therefore the area, area 1 and area 2, when you add area 1, so therefore area 1 plus area 2, so therefore area 1 plus area 2 is with the positive, which is 2 plus 2 root 2. Alright, let's find the area now for area 3, which would be between this limit, this is what now? This is, and the 3 pi over 2 limit. So this limit is pi Alright, to get area 3, we could just work this out. Let me put it in a different color. Use green. Now area 3, which is what we want, is the same as this area. So to get area 3, we can just find this area in green. This is easier to identify the limits, and the limits here for the area in green between the curves is 0 pi over 4. Alright, 0 to pi over 4, same as area 3. So to get that area, alright, area 3 is the integral between 0 and pi over 4. And we'll just take a difference of the function, again, cos x minus sin x. Difference of the two curves. So we have the integral already, integral of cos, we have it here, is sine. And the integral of sine is cos. But the double negative, so the integral of negative sine is actually positive cos. And the limits are pi over 4 and 0. Alright, so we form two brackets. First bracket replace x with pi over 4. So sine pi over 4, that's root 2 over 2. And the cos of pi over 4 is also root 2 over 2. And then minus, in the second bracket now, replace the x with 0. Sine 0 is 0, but cos 0 is 1. So minus 1. So the first bracket is 2 root 2. Again, same thing, is 2 root 2 divided by 2. Alright, since it's a common denominator, you just add root 2 and root 2. That's 2 root 2 divided by 2. So it's just root 2 minus 1. Alright, so the total area, which is area 1 plus area 2 plus area 3. So the total area, so the solution, the final answer, the total area is area 1 plus area 2 plus area 3. So area 1 and area 2, we have 2 plus root 2 for that. 2 plus 2 root 2 for that, sorry. And area 3 in green there, same thing as what we have in area there, is this small area there is root 2 minus 1. So we add up everything. So root 2 and root 2, that's 3 root 2. And 2 minus 1, that's positive 1. So the full area is 3 root 2 plus 1. So that's, and the area, so square units. On the surface of the moon, the acceleration due to gravity is negative 1.625 meters per second square. A rocket is launched away from the moon with an initial height of 1200 meters and an initial velocity of 30. Determine the velocity and height of the rocket. Hold on, I think I've gone too far. 5 seconds after launch. So we all should know that acceleration is equal to change in velocity over time. Alright, so dv by dt. Good. So we are given the acceleration, negative 1.625. So negative 1.625. That's what the acceleration is, right? So dv by dt is negative 1.625. So if dv, so if we have v and you want dv by dt, you differentiate. Alright? If you have dv by dt and you want v, you do the reverse, which is integrate. So we're going to integrate this. So integrate with respect to t is negative 1.625 t plus a constant. Notice if you should differentiate, find dv by dt, you'll end up back with that negative 1.625. Differentiate, of course, with respect to t. So we need to find the constant. Alright, so we're told that initial velocity of 30. Alright, so initial velocity of 30 means that when t0, v is 30. Initial velocity of 30 meters per second. Alright, so when t0, v is 30. So we can substitute. We get v equal, when t0, v is 30. So v0, my bad, I'm interpreting wrong. Hold on. When t0, v is 30. So right there I have v is 0. When t0, v is 30. So v replace v with 30. If t0 will have 0 plus c, therefore c is 30. So the equation for velocity is negative 1.625 t plus 30, and we're asked to determine the velocity and height after 5 seconds. So to get the velocity, replace t with 5. So substitute t equal to 5. We end up with v equal negative 1.625 times 5 plus 30, and this is negative 1.625, so that's 1.625 times 5 at 30, I'm getting 21.875 meters per second. Now we also asked to find the height, alright? The height, same as displacement. So v is equal to that to get the height. So dh, so v is the change in height over time, or change in displacement over time. Alright? So dh by dt was what the velocity represents, which is negative 1.625 t plus 30. So dh by dt is this function. So if I want h, so how it works, if you have h and you want velocity, if you have h and you want dh by dt, you differentiate. And if you have dh by dt and you want h, you integrate. So h would be the integrate. So, yes. So remember, v is change in displacement over time. In this case, displacement, as we said earlier, is height. So change in height over time. So dh by dt give you v, which means if you want h, so this is equal to dh by dt. So therefore, dh by dt is negative 1.625 t plus 30. So if you want h, you would have to integrate, alright? So if you have h and you want dh by dt, you differentiate, and if you have dh by dt and you want h, you do the reverse, which is integrate. Alright, so integrate means we add 1 to the t power. So negative 1.625 t squared over 2, integrate 30. Look at 30 as 30 times t to the power 0. T to the power 0 is 1, so 30 times t to the power 1 divided by 1, which is just 30t, plus a constant. And we are told that the initial height is 1200 meters. So in other words, when t is 0, the height is 1200. So when the height is 1200, when t, so you substitute t equals 0, initial time, h is 1200. So replace h with 1200, t 0, so all of this will become 0. 30 times 0 is 0, so the constant is 1200, which means therefore that the height, so therefore the expression for the height is negative 1.625 t squared over 2 plus 30t plus 1200. And to get the height after 5 seconds, we substitute t equal to 5. So we substitute t equal to 5. So substitute t equal to 5. We get h equal negative 1.625 1.625 times t squared, so times 5 squared, divided by 2 plus 30 times 5 plus 1200, and we should end up with h equal to negative 1.625 times 5 squared, so times 25, equal divided by 2 plus 30 times 5, so 30 times 5, that's 150, so plus 150 plus 1200. I'm getting to the nearest whole number, 1329.7. So the final section. So integral of cos cube 2x times sine 2x. So let's rewrite it as cos 2x all cube, that's what it is, times sine 2x dx. So this type of integral, we should be able to recognize it. Notice you have cosine and you have sine. One of them is raised to the power of 1, and the other one is raised to another power. So we simply, the one that raised to the power, that's not 1, in this case is a cos 2x. We simply just add 1 to the power 4 and divide by the new power, plus the constant. No, it's not completed yet. We need to differentiate this using the chain rule just to test if we have the correct integral, because that's how you test if you integrate something correctly, by differentiating it. Differentiate the integral and you should get the original expression. Remember, differentiation and integration are the opposite to each other. So let's check if we have the correct integral. So 4, using the chain rule, so 4 times the bracket and I will subtract 1 from the bracket, leaving 3. And I will differentiate what's inside of the bracket. That's the chain rule. Differentiate cos 2x. What we will get is negative 2 sine 2x. Notice 4 into 4 cancel. So what you end up with is the original expression times negative 2 here. Notice the original expression, cos 2x all cube minus 2 times sine 2x. So notice the original does not have a negative 2. So to get rid of the negative 2, we need to divide by negative 2. We'll put it down here, or you could say multiply by negative 1/2. So this rewritten will therefore cos 2x over 4 to the power of, over negative 8. Now let's check again if this is a correct integral for this expression here by differentiating. Let's differentiate in our result here to check our solution. So differentiate, chain rule, multiply by the power, put it in, multiply by the power, the bracket by the power, and then we subtract 1 from the power, right? We get 4, remember there's a negative 8 below. And then I will differentiate what's inside of the bracket. So differentiate inside the bracket. Differentiate inside the bracket. We end up with, differentiate cos 2x. We end up with negative 2 sine 2x. Negative 2 sine 2x. Now notice in the denominator, in the numerator, you have negative 2 times negative 4. That's negative 8. So negative 8 in the numerator will cancel with negative 8 in the denominator. By the way, we should have subtract 1 from the power. When we differentiate, remember we subtract 1 from the power, right? So what we have is cos 2x all cube times sine 2x. So we are confident that this is a correct integral for what we're given to integrate. And that's it.